Afternoon, sir.
Thank
Aye,
you.
Senjani.
Good and leadership blessing.
Aye,
Sorry to come
Njani.
late. Sorry to come late, blessing.
No, what problem?
Thank you very much. These are just updates, ne? The updates will about the quiz tomorrow during tutorial. I want to mark first. So now I want us to conclude the chapter 2. First 45 minutes. The second 45 minutes, I have to introduce the new chapter, which is analysis of covariance. So this first 45 minutes, we discuss the remaining section related to model 2. I think we'll need roughly 30 minutes to do that. And the other 15 minutes, we can use it to revise the model assumptions. There's a section which is focused on the model assumptions, which I think can have 15 minutes talk about, because that one is theoretical. But the first 15 minutes, let's focus on the variance components. About the quiz, please hold your horses. Tomorrow, I want to mark all the scripts. Some of you guys, you received your marks. Some of you didn't receive your marks. I'm left with only 65 scripts to mark. Some of the information, I assume you received an information from your class rep regarding late submission. But to talk about that, let's do it tomorrow during the tutorials, because we don't have a lot to discuss. And then again, if you answer memories question, even though it's not part of that now, seeing the memorandum, maybe we can do the memorandum so I can give you an idea on what was expected from you, and then you will see your mistakes, because I hear you scanned the work, so you still have what your original work with you. So you compare your original work and what others managed to do. Because so far I have, I think, more than 10 students who got everything right. So it shows that we're moving in a right direction. Even those who failed, it's not like first semester where people are getting 1 or 2s. Even those who are failing, the way they're failing, it's not that bad. But there are people who are dramatically failing. I don't know what is the problem, but let's because the test is no longer far anymore. So let's use this time to do the content part. Tomorrow, I assume I will be done marking everything. Then we can talk about late submission and what was expected from you. So last week we spoke about model 2. We spoke about model 2, which is the random effect model. The way you construct your ANOVA table is the same way you construct the ANOVA table for random for model 2. But what we are testing is not what we are testing under model 1. Here you are testing if the variance of the treatment is greater than 0 or is equal to 0. We did an example last week. After, if there's a part where you'll be asked to find the variance components, but you can only do that provided you have rejected the null hypothesis. It's necessary to find the variance components. What are the variance components? I discussed with you that we have two variance components. Is what? This is the first variance component. I gave you the formula last week, and then the one is this one, right? We have a formula here that is attached to that one. And again, I spoke about the total variance, the variance of y ij. I spoke about these things last week. So now we'll be moving from this part here. Now, since we know this, find the confidence intervals of the variance components. The variance components. So it means, as I've indicated, that we have two variance components. Oh, sorry, Christopher. Sorry for using blue. The default color from this is blue. So it's not like I didn't respect your sorry. I didn't respect your suggestion of using black. Sometimes I forget. Yes, Mashudu.
Sir,
Yes.
I wanted to ask about the second component, the R, because sometimes our replication might vary. So
No,
what
we
are
expect. I will only give you in a case where you have equal replications. Are we cool, uh,
yeah,
my brother?
yes, we are cool. Yes.
Another challenge is you guys. I'm not you specific. If you check my last year, um, my last year, what do you call this thing? Question papers. You'll be frustrated. Why? There's some of the things that I covered last year, which I decided not to cover this year. Do you understand, guys? So as long as I didn't talk about that, those don't worry about it. But I'm not saying you should not ask like what my brother asked now. If you have a question, ask, and then I'll clarify you. That one I'll never do it, my brother. But doesn't mean that if you check my previous question papers, you won't find it. If you check my previous question papers, you can find a question like that. But for this year, it's not. You should not worry about it. Because if you have unequal replications, you must do what? For you to use the formula, you must estimate. You see, estimate using the harmonic mean formula. But you should not worry for this semester as long as we're focusing on model 2, the problem will be a balanced problem. I hope I have answered your question, my brother.
Yes, we did, sir.
Okay. So, um, what is the formula for the other component? You guys are preparing for the test. What is the formula for the other component? Yes, Mashud, your hand is still up. I assume you want to give me the answer now.
1 over R.
Okay. Sigma squared. Yes.
1 over
1 over
R,
R.
open bracket, MST minus MSE.
So for the total variance,
It is the summation of both components.
okay, thank you. So now we move to the confidence intervals for the components. We have two confidence intervals for the various components, and the table that we'll need now, that is needed here, is the chi-square table, which I'm not sure if I shared the table with you. If I didn't share the table with you guys, it means you must go and look for it from the internet, please. Otherwise, guys, after, because it means now I have to solve the problem for you, isn't it, guys? Because I prefer you guys to be the one solving these problems, because if I'm the one solving, we're not moving, right? I prefer that you should be the one solving this. So the formula is given by confidence interval for the error, which is the first part. Sorry. So confidence interval, guys. I'll give you the confidence interval for this one here. I think this one you have it from last week, right? And the confidence interval for the other component. So this is given by for the error confidence interval for the. So I want you guys to do the calculation, please. Is given by confidence interval for the error. Confidence interval for the error is given by SSE over A. Anyone who downloaded my notes, last week notes, I want you to confirm this formula, SSE over B. Anyone who downloaded my last week notes, I want you to confirm this formula, where A is given by the chi-square value. So this is the tabulated value, guys. Alpha over 2. And then N, a capital letter M. And then the B part is given by chi-square value. This is the denominator, guys, is the value from the chi-square table. 1 minus alpha over 2 n minus t. Can someone confirm this information for me?
Sir,
It's correct, sir.
Yes, Christopher?
I was saying on your chapter 2, part 2, I see the numerator saying times MSE. N minus small letter a.
N minus small letter A.
A.
Yes, you remember, Christopher, I said the document that I shared with you, the notification, the notation is different from the guide. So I will try to give you a notation which is equivalent to the guide. That is why I'm giving you the formula. Use the one that is written here. Because A there, it represents, we find that according to A there, it represents the treatment. Do you understand, Christoph?
Yes, sir.
Or A is the replication. So I don't want to confuse you. Whenever you see R, R is the replication. Whenever you see T, T should be what? For the treatment. Whenever you see a capital letter N, it means the population. So that is why I said, I think I said it last week that sorry for the document that I shared with you concerning the notation. The notation can confuse you. So let's focus on the one that I'm just giving you today, leadership, Christoph. Are we cool, Christopher?
Yes, sir.
Please. Okay, sure. Thank you, my brother. So now let's move to. We'll do an example. We'll Matume, are you here? Matume?
Yes, sir.
Yeah, you'll help us with the. You'll help us with the. Remember, we did an example about. Oh, it's fine. It's fine. I will project it. You lead the group. Ne? I will project the ANOVA table of the problem that we did last week, right? And then you will guide us on how to use this formula. So copy the formula, you guys, please copy the formula, and then I will project that worked example from our notes, and then I want you to try to apply this formula and check if you understand what is happening. So now, allow me to write the second formula, guys. So this is the confidence interval for the first component, right? Which is the error. Now I'm going to give it another confidence interval for what? For the sigma squared tau. So now allow me to give you the second confidence interval for the second component. Confidence interval for the component for this second one now. Now, this one now, remember, the tau goes with what? The tau goes with the treatment, right? So it means the formula will be what? SST divided by the number of replications multiplied by C. Sigma squared head, or sigma squared, sorry, it can't be head because this is what we're estimating. SST divided RD. The reason why we said it's not necessary to estimate, why we say sometimes it's not necessary to estimate the variance of the taus is because if you know that it's equal to 0, why are you still estimating? So, but if you are sure that it's not equal to 0, you must estimate that your variance of the variance of the treatment means is within this interval. Now, please, even this one, please copy it down. From there, you take over. Let me write it using a different color so that you see it's not part of the formula. If time allows, we can even talk about the quiz today. But I wanted to finish marking everything before we can talk about the quiz. Christopher is against red color. Let me use this blue. C is equal to chi-square table alpha over 2. Remember the other one was the degrees of freedom of error, right? Now we use the degrees of freedom of the treatment. And then D, same thing. D is given by chi-square alpha over 2 T, oh sorry, 1 minus, sorry. This is the right side. 1 minus, guys, sorry for that. T minus 1. The right side is chi-square 1 minus alpha over 2 T minus 2. So have these formulas, guys, and then, or maybe I should also give you the confidence interval for the ratio, which is the last one. If we do this one, it means we're done with random effect models. For random effect models, you must know how to fit the model. You must know how to find the variance component. You must know how to find the components. And again, you must know how to estimate the total variance. The last one, you must know how to find the confidence interval for the ratio, which is the last one. The confidence interval for the ratio. I'm about to give you the confidence interval for the ratio now. So before we can move to that, the last one is the complicated formula. Before we can move to that, allow me to share the note that works. Those who are having a chi-square table, you will help us with the tabulated values because you have been using a chi-square table from first year. So what matters is that you must know whenever you want to find the variance components, you should use you want to find the confidence interval for the variance component, you should use the chi-square table. So those who already have the chi-square table, it will help us with what? The tabulated value. So allow me to share the example that we did together last week. So I want you to find the variance components together with their confidence intervals. Allow me to close this. Let me share that page with you guys. Matuma, are you ready?
Yes, are you talking about the example that we did during the tutorials?
Yes, I want to share the. No, I will share the what? I will share the notes with you. It's the one that you have on Blackboard. The very same notes that we have on Blackboard. You remember? I shared with some. I'll project the table, but I want you to lead, to ask them to find those variance components, and also to find the confidence interval for each component. That is your responsibility, Matum. Only that. When you are just directing them. Let me share now. I'm sharing the file, Matume. You remember that file, Matume, right? Remember, this is one of the formulas that we are expected to find, isn't it? not for the rest. So the last one will be this one, guys. The last one is the confidence interval for the ratio. If you can check, the numerator is what? The variance, the confidence interval, sorry, the variance of the tau, and divide by what? The addition, isn't it? So this will be the last one. So I want us to focus on those two first before we can get to this one. Here's the information in leadership. Matume, are you still there? Matum.
My network is kind of tripping today. I don't know what's wrong.
Yeah, you can, if you're having network issues, you can ask someone to help you. You are in charge.
I think Tuto can take over.
Guys,
take over what, sir?
You ask your members to find the variance together, or maybe the first question should be, is it necessary to estimate the variance components? If yes, find the variance components together with their confidence intervals using the given information.
So first, they must do the Hartley test.
No. To find, remember, Hartley test, variances are equal, right? This one is, you are checking if the variance is greater than 0, right? I said if you reject the null hypothesis, it means it's necessary to do what? To find the variance component. Isn't it, my brother? Well, let me share the document in this format. Share file. So let's help Christopher, guys. If wherever is getting lost, please let's help him. Where team here. I'm trying to open it using a different.
So say from that ANOVA table, we're gonna need the.
I'm listening to.
From the ANOVA table, we
Yes.
need the F tabulated and the F critical.
Yes.
We are going to use here.
No, or maybe let someone help you on that one, guys. What is your conclusion here? You are using model 2, right? What would be a null hypothesis? Anyone who still recall? What did I say about the null? What would be a null hypothesis in this case? Tato?
I think
it will be the variance of the tau is equals to 0.
Yes.
Then alternative, it's the variance of the tau is greater than 0.
You remember this, Chris? We said the variance of is equal to 0. This is what we are testing, Christoph. That's why the follow-up questions were assessing the variance components in it because of this hypothesis. So this is what we are testing. So I said if you reject the null hypothesis and conclude that, if you reject the null hypothesis and conclude that the variance is not equal to 0, if you are against this one, you say the variance of the tau is not equal to 0, it means you want to know what the values that can be assumed by what, by the variance. Sorry, this head is not supposed to be there. You understand, Christopher and others?
Yeah.
Yeah, so can you please take over, Christopher? Ask them to find the variance components and find the confidence interval.
Okay, guys, can I please have the variance components of the 5 treatments? The variance components, guys.
So Christopher, gather all the information. When you are done, you let me know. You must, those who are having the chi-square table, ask them to tell you what is the table. Those having the chi-square tables. If while others are giving you answers, some they can simply what, check for chi-square table from the internet. Work with him, guys, please. Next time it will be you who will be controlling the class. I thank you.
Okay, so here's the YIJ. So are we gonna test this variance against the chi?
That is the question. The question is, what is it necessary for us to estimate this component? Let's start from there. Is it necessary for us to test for this component, and why? To check for, to find this component.
Okay, so guys, are we gonna reject the null hypothesis?
Yeah, we reject null hypothesis.
There is a hand from Terson.
Yes, Christopher, we reject the null hypothesis.
Okay, so now after we reject, what are we gonna test against our chi value?
Or it's fine. Let me come in. The reason why you have to find the variance component is because you notice that variance of tau is not equal to 0. That is why now you are estimating these things. So it means you can also estimate. You can try to estimate what? The variance of the tau. So you estimate the variance of the tau using the chi-square table. That's what we're doing now. So now you manage to find the variance components. Move to the confidence interval for the component. Find the, so please ask them to give you the tabulated value from chi. You can start with any confidence interval as long as at the end of the day you have the 2. Let me not disturb Christopher. The stage is yours again. If you want someone to help you, or to work with you, feel free. You can ask someone to work with you from the class. You are in charge.
Yeah, I need help, sir.
Ask them who.
Okay, here's the first chi value for. What is it for? The chi value for confidence interval for what? The error. Let's start with the error. Twenty comma 48. What is it for? Matsemela. Okay, for A. And then for B, I'm getting two answers. Which one is correct? 5 or 3? I'm getting two answers.
The correct one is 3.247.
Okay. So once we our A and B, what is our lower limit and upper limit?
Zero 0.88 and 5.54.
So this means our error. So what does this mean? I don't know. What does this mean?
Since the interval does not
Okay.
include 0, it means therefore it's true that that thing is greater than 0.
No, you are just estimating that your error can be within these two, nothing more. You don't have to interpret the confidence interval as long as you present that your estimated sigma squared of errors can lie within these two values. That's all. You don't have to explain more. So find the other confidence interval for the which goes with
For
the
the term.
treatment. Yes.
Okay, first, what is the value of C? The value of C and D.
C is 11.143.
And D,
I'm getting 0.484.
okay, so let's find our lower and upper limit.
If this is how you guys you discuss during our quizzes and tests, that is why you are not finishing. Why are you taking so long?
The upper and lower limit, guys. Okay, so which one is the upper and the lower limit? 13 or 4?
Four is the lower limit.
And then which one is the upper? 104, 101.
Sir,
So how are you going to interpret?
Here you are not interpreting, you are estimating that your variance for the taus can fall within this. Because you are you can simply say you are 95% confident that if you want to interpret, you are 95% confident that the true variance of the taus can lie within what? Within that interval. The other one is the true variance of the what? Of the errors can lie within that the two interval.
sir,
They're asking you, Matitele, they're saying, what is your R?
Sir,
Yes. Who's talking?
Smanga.
Okay, Smanga.
Okay, that's fine.
Smanga,
What
listening.
were you asking? What were you asking?
I didn't ask anything myself.
Oh,
It's not me. It's the student who was saying, what is the value of R?
oh, the value of R is 3. There are 3
Malima,
replications.
Malima, you just joined. I assume now, guys, you are doing the one for the tiles, right? Which needs C and D, not A and B. A and B, we did this one long time ago, unless if I'm confusing the two. So my advice, guys,
sir,
is that whenever I do something, do it with others, because now this thing is reflecting from the quiz. You can see that there are people who don't even know what is happening. It's clear that these ones that are still lost. So we're not moving. Babund.
Yeah, sir, students want to go to a break. They need a break.
Thank you very much. Let's meet after the break, and then
How many minutes?
It's 10, right? So it means you come back at what? Is it 5 to?
Oh, okay.
Yeah, 5 to 2, and then we do the last confidence interval, which is the interval of the ratio. From there, we move to the last section about and the other chapter will be introduced tomorrow. There. Those who want to see me in the office, you have to come immediately after this class. Those who want to see me, not via the thing blackboard, you can simply come immediately after the quiz. I don't mind to wait for you to allow you to consult for 30 minutes. So you can consult from 2:30 to 3 o'clock. Those who want to see me, I'm not saying it's a must. So in the meantime, I'll be writing the last confidence interval here.
Sir,
Yes.
when we come back, can Mr. Skhutlabora please take over?
I hear you, Christopher. Thank you very much for your help. Thank you very much. Mara, let me do everything when we come back from break. So that, because otherwise people will be afraid to go because I'll be writing something. I'll write something when you come back. Thank you. So we are taking over class rep. This is the responsibility of
Sir.
blessing. Yes.
Oh, I was testing if you can hear me because I've been saying we can continue.
Oh, okay. Thank you very much. Now let's do the last confidence interval. Musibudi, will be in charge. The formula, this now is the confidence interval of the ratio. Confidence interval of the ratio. Musibudi, you'll do this one. Confidence interval of the ratio is given by is given by 1 over, L over 1 plus L. Here's the ratio that we're talking about. Is the variance of the tau divided by the total variance, right?
So are you writing something?
Yes, I'm writing. Even you guys, you cannot see what I'm writing.
We can see, sir.
I can see.
Now the upper limit will be given by U divided by 1 plus U. So now what you need now from me is the meaning of what? Of the L and U. Otherwise, from there now, you'll be able to do what? To do any calculation. Where now U, L, sorry, let me start with the smaller one, the lower limit one. L, you can still see it, right? L is equal to 1 over R in bracket, just to make life easy for you, F calculated, multiplied by you multiply it by 1 over F alpha over 2 T minus 1 N minus T. So again, Christopher, even this one, please use my notation, because if you have to check the one from the notes, it can confuse you. So use the one that I'm giving you now, Christopher. The one from the notes that one can confuse you. So this is your lower limit, guys. Wherever you have, put this formula here. Okay. What about now? I think this is the last part. What about now, leader? Can you see now? Sibula is saying no. Sibula, I cannot see anything at all. Manka is saying you can see them now. So Manka is sorted. What about Sibula? Sibula maybe is having a network issue. This one. Sibula, check your network. So the upper limit is given by the upper limit, which is U, is given by 1 over R F cal. Get this information from the ANOVA table, guys. Multiplied by multiplied by 1 over F 1 minus alpha over 2. Or let me extend this. Alpha over 2. What are you saying? Is someone who said something now?
So can you write this on the whiteboard?
I assume if you are saying that you have this ANOVA table, right? Because you need it.
Yes.
So can I close this? So you have this information. You won't expect me to come back and because I was writing it here because now you will need what? Now you will need the F calculated. You see? So if you're saying I must go to the whiteboard, I assume you have the complete ANOVA table. Can I move to the ANOVA to the whiteboard? I don't have a problem to do that. So they're saying I should. Can I close now?
Yeah, you can close.
Thank you. The upper limit is given by, I'll also write the lower limit, it's fine. For those who didn't get it, let me clear this. What's this people that I'm making a little noise here? Sorry. Yeah, I will correct even the lower limit if I didn't write that -1. I thought I wrote it. I'm trying to summarize the formula, so maybe the time I was trying to summarize it, I ended up making a mistake. Minus alpha over 2 t minus 1 and n minus t. Sorry guys, here there's -1. Thank you very much, Shogani. I'm the one who missed it. This part, let me divide this so that you understand what is happening here. This part is the tabulated value. You get this information from the table, guys. You multiply it with, sorry, up to here. This information, you get this information from what? From the table, the F table. So the reciprocal here, f of, I want to do with this one, f of 1 minus alpha over 2 t minus 1. This one is very, very important, guys. N minus t is equivalent to 1 over f alpha over 2 t minus 1. Now, here there will be a change now. Can you hear me, guys? Can you hear me?
Yes, sir. Can hear you.
Thank you. Now, check what I'm going to do now. You switch the degrees of freedom now. So I don't want people to say this one. You see, it was t minus 1, right? It's t minus 1 and minus t. But because you want to get rid of this part here, you want to change this to alpha over 2. So you will say, n minus t, n minus t, t minus 1. Can you see it? This is 1 over 1 f of 1 minus alpha over 2 t minus 1 n minus t is equivalent to 1 over alpha over 2. You switch these two. You switch this one. You take this one to be the first one, to be v1. You take this one to be v2, or d1, d2. Remember from your table, this goes with what? This goes with v1, is the degrees of freedom of v1. This one will go with degrees of freedom of what? Of v2. So you please get this notation right, because there's no way that you can get a table of 97%. So you want to go back to a table of 0, 0.5, 0, 0.5, 0, 0.01. But if you use this formula here, 1 minus alpha over 2, let's say our alpha is 5%. Let's do it, guys. Suppose our alpha is 5%. What will be 1 minus alpha over 2? Yes, Matato.
Sir,
Yes.
I didn't get that formula, confidence interval for of ratio. Can you please write it?
The confidence interval of the ratio, right?
Yes, like the formula where you said, I think you said lower limit over something. I didn't get that formula.
I will write it after writing the other one. You see, so it means now, I'll do that, my brother. So it means now you need a table of f. You said it's what? F is it 0, 0, you see, you need a table of f of 0.95. You see, 975. Sorry, you need the table of 0.975 degrees of freedom that we have. What's our degrees of freedom based on that example? What was the degrees of freedom? Is it 2? The example that we're doing now. What is the degrees of freedom? The person who asked me to move to the whiteboard must give me the value. What is the degrees of freedom of treatment? It's 4 and 10, right? So you see the challenge now is what? The challenge now is the table where you'll find why are you going to find this information? From which table? Because now it means you need a table of 0.975. Where will you find it? So this, whatever you wrote here, is equivalent to is equivalent, based on this example, is equivalent to 1 over f of alpha over 2, 10, and what? 10 and 4. Again here, don't confuse this one here and this one. This one, these are two different things, isn't it? This one is from this reciprocal, but this one is part of the formula, isn't it? So in other words, we are going to have 1 over f of this part here, the numerator, the denominator, sorry. So it's to be 1 over f alpha over 2 n minus t minus 1. And then don't forget to minus 1 there. So I was informed that to write the first formula for u, I missed the what? I missed the minus 1 part. So let me repeat that formula again. Let me write that formula so that you get the right thing. The lower limit is given by 1 over r f cal multiplied by 1 over f tabulated. You know what is f tabulated. I gave you the information. This is the formula. The upper one, I can write it 1 over r f cal multiplied by 1 over f tab. Allow me just to put a star so that you know that these are not the same thing. This is not the same as the f tab from the upper part there, minus 1. The formula I said is L divided by 1 plus L, and the upper limit is U divided by 1 plus U. Are we fine, Matato?
Yes.
So this is the confidence interval for the ratio. So guys, I want you to find the confidence interval for the ratio based on that given ANOVA table. This is the last confidence interval that we have to do. Find the confidence interval for the ratio. Who's supposed to do this one? You said this. Who's supposed to do this one, Christopher?
Mr. Skotlabraga.
Skotlabraga, Matume, if you are not ready, suggest the name. Here you just have to find the lower limit, the upper limit, and then you're done. The important part is to know how to find the value from the table.
Sir, Orkolofelo can help us, Mr. Shokan.
Let's try.
Okay, see. Yes. Why
You hear
listening,
me,
my
Shay?
brother?
Yeah, let's try it.
Yes, F calculated.
Let's try it, but if I'm kicked out, can we find F calculated, guys? For the lower limit.
Let's find R. What is our R? Let's save time because I noticed that this information is not coming fast. What is our R? Number of replications? I'm told it's 3. And is it 3? It's true, that is 3. Oh, you're right, it's 3. I just confirmed my answers. What is F tab? F tab, the upper one. Let's suppose we are using 10% table. Our alpha is 10%. Suppose our alpha is 10%. Our alpha is 10%. When you divide 10% by 2, what are you having? Guys, is alpha over 2. F of alpha over 2. So suppose our alpha is 10%. What will be our F? When alpha divided by 2, we get what? Suppose our alpha is 10%. Alpha. Thank you. I want us to move to that table of 5%. Suppose our alpha is 10%. It means you are right. The value is what? The value is 3.48. So be careful, guys, because before you go to that table, you must first find the divide the alpha by 2 before you decide which table to use. And then F tab star. F tab star. Is equal to what? This one I want to write it as 1 over, give me the value from the table. So you're going to check for what, guys? F tab star. F tab star, you are going to check for what? 1 over F of what is the degrees of freedom of error? What is the degrees of freedom of error, guys?
10.
10. You are going to check for 10 and 4 from the same table, isn't it? So what are you having? F tab star is 1 over what is this part? 5.96. So there's the information, guys. Based on that given information there, you'll be able to complete what? The lower and the upper limit. So please do it. Tomorrow during the tutorials, we'll try to come up with an example where you can apply these things. So that's how you find the confidence interval. If you check the formula the way it is given there, it looks complicated because instead of saying F calculated, from the formula there it says MST divided by MSE. But we know that MST divided by MSE is what? It's the F calculated. So I tried to summarize the formula for you so that it look nice. So when it's like this, I think it's more than better. So please, guys, let's work together to go and complete. So the last
Sir.
part they were, yes, who's talking? Oh, it's Manga.
It's Mang. I think I'm a little bit confused here. You are saying on F tab star. In which table we are looking for? Where did you find the value?
It's not me. Hey, ask Shokan. Manga is having a question.
Because here we are looking for F calculated of degrees of freedom is 2 and is 4
Is it
and
2?
10, right? Is it
I'm
4
told
and
it's
10?
4 and, I'm told it's 4 and 10.
4 and 10, and it is alpha is what?
5 is 10%.
10%. The answer should be 3.478. I don't know if it's for the lower or for the upper.
Smang, we said the degrees of freedom for F tab is alpha over 2t minus 1 n minus t, right? And you'll get 3.48, isn't it?
Okay.
There is the value there.
So I can see that one. The other one, 5.96. Where is it from?
Dineo, can someone explain where we got the 5? Here it is, Mang. I said F tab. Can you see this part, Mr. Mang? This part here.
Yes, I can see where you're on that.
Yes, it says F tab star is the same as 1 over alpha over 2 n minus t minus 1. You switch the degrees of freedom, Mrs. Mang. At first you said you looked for from the table of 5%, right? You looked for 4 and 10, isn't it? Is it, Mrs. Mang?
Sir.
I'm not sure. Yes.
Sir. Yeah, now,
Yes.
now I can see it. Thank you.
Okay. So the last part, guys, that we have to discuss with the remaining 5 minutes is the model assumptions. This one is theory. We don't have to do any calculation unless if you are expected to transform the data set. Remember first semester? Remember first semester, guys? Where Mr. Masongani will ask you to transform the data. He also explained how to transform the data. He gave you some methods that can be used, isn't it? Mr. Masongani, from when you guys were doing what is that? When we were doing a time series. So even myself, I also spoke about these methods, but we didn't apply them. But now I want you to understand how do we apply this method. No, it's the limit, right? Can't be. Means you made a mistake if you have that type of a situation. So we have the last part, guys. This one is theory. So you must pay attention again here because it's possible that I can say before doing any calculation, transform the data set first. Ask you that. Or I can ask you that if you are testing for the equality of variance, if you reach this conclusion, format, go and what? Transform your data and do the calculations again. Did you hear me, guys? When you are dealing with oh, I opened the wrong file. I'm looking for part 3. Oh, it is here. Sorry, guys. I want to share the part 3. The part 3. You have these things, this part from your Blackboard. The last part, guys, is this one. This document 7 pages. So it's all about checking the model assumptions, diagnostic, and the remedies. If some errors are violated, some of the assumptions are violated, what can you do? That is the only question that I'm asking. So we know the assumptions, right? Or can someone remind us about the measure assumptions or the assumptions of the model? The 4 assumptions are what? Can someone still?
So that the errors are independent and the variance of the mean of the error is 0 and the variance of the error is sigma square.
Yes, so please understand the assumptions of the model. Here they are. We spoke about this. The model is correct, but this one is not the assumption. That we spoke about the assumptions. I think when we're talking about the variance, the ANOVA table. So these are the model assumptions. The model is correct. Independent observations. Errors are normally distributed, and the constant variance. So the one that Mr. Smanga was giving me is the way that ones are related to the ANOVA table. So don't worry about the proofs. The main focus is what? The main focus is to know how to check for these assumptions. Here is the what? The direction on how can you check for these assumptions. We said the normality plot. I even said it last week. You can use the histogram of the residuals. You can use the what? Normality plot, which was discussed at the last lecture. Remember? Lecture. I did another part. This one I said is it will be lecture 4. Remember, we have lecture 3, right? The one that I promised you that I would give you the document, but still I'll give you the document. The Shapiro test, you don't have to worry about this one. I have to include it because of someone asked about this test. So there are a lot of tests that can be used to what? To deal with this method. You can Wilks test, but for now, for your level, you don't have to worry about that. The constant variance, you can use the residual plot to check for the constant variance. Guys, your answers are disturbing now. Unless if I will let me so that we finish because I'm losing focus here. People have let me not allow you to post anything because now disturbing. Because I'm talking about this later on, you will want to ask me about the very same thing. So I'm saying, how do we check for the assumptions? One of the assumptions is the what? The normality. Normality, you can use the histogram of the errors. You check if the histogram is what? Is symmetric. It's not skewed. If it's skewed, you can use the normality plot. The Q or sometimes we call it the QQ plot. You check where those errors are. Those errors, they must form a what? A straight line. If they're moving away from that line, means there's a problem there. The Shapiro test, you don't have to worry about this one. It means that's where you expected to do it using calculations. The Shapiro test, you can use calculations. Constant variance, the scatter plot of the errors versus Yij hat. You estimate using what? The given information. So if you check some of my papers, you'll find that there was, I will give you these plots and ask you to comment about our model. So you must know how to explain the what? The histogram of the errors. I can give you a histogram of errors versus Yij. So the Bartlett's test.
Sorry.
Yes.
Oh, first, can you please start from normality?
Which part, my sister?
From normality.
I mean, there are 3 points there.
Okay. This one here, histogram. I
What did you
understand
hear
it, but
about?
it is not skewed to the right or left.
Yes. I'm listening, Kadimering.
Then from there, I didn't hear anything.
Not run fast, it's just you didn't hear anything. Yeah, so it means I was trying to correct the language that you used. Remember, my sister, for the QQ plot, you find a line like here. When you check the errors should be what? Should be closer to the line. You see what is happening with this one here. What I'm trying to draw here. But if you find something, my sister, taking this direction, let's say we have this one. Now let's focus on the red part. Do you see what is happening, my sister?
Yeah.
It means the red part, it's simply telling you that there's a problem with your model. The errors should follow what? Should follow a straight line pattern, like what is happening with the blue dots. You get it?
Okay. Yeah.
So this is the QQ plot, the QQ plot. QQ plot. The histogram, if the histogram is symmetric, you know what we're talking about, isn't it?
Yeah.
If we say the histogram is symmetric, you know what we're talking about. So now, the so-called errors versus errors against lower your hand in Kadiming so that I can write here. Lower your hand. Thank you. Now you have what? Yij, the estimated values from the model. You estimate the values and you find the errors this side, the estimated. So you remember, errors can be positive or negative, isn't it? Errors can be negative or positive. So here, whatever you're assessing here, you don't want to see errors forming any pattern, isn't it, my sister? Errors should be random. Random. The errors should not form any pattern. Do you see it, my sister? Do you see what is happening, my sister? Do you see any pattern of these errors?
Yes.
Do you see any pattern?
No.
No, I heard you saying yes. But if you have a plot like this, maybe for the errors, you find that the errors are creating this shape. Do you notice the difference between the two? Between the first plot and the other? You see this one? There's a shape that is these errors are causing here. So that's where maybe I can say, if your results are like this, transform the data set. So on the podium, please, what other tests can we use except the ones which are listed here? I'm asking Kadiming. What other tests can we use to check for constant variance? Kadiming?
Oh, constant variance.
Yes. You did it from it was there on the quiz, right?
Yeah, ke Hartley.
Yes, Hartley's test. So there is only, I spoke about the Levin test. Levin test, there's a lot of work because you must find the medians for each treatment. You must find the median for each treatment. From there, you minus the original value from that. That is a lot of work. But if you want the test of the Levin test, I don't mind. I can teach you how to do it. But it's a lot of work. Immediately I teach it, it means I'll bring it. The Levin test. It's a lot of work. You can also use it to test for what? For the constant variance. The independent of errors. This one, as I indicated from first semester, the data set should be related to what? To time series data set for you to check for what? For the independence of errors. The outliers, as you know, guys, outliers can cause a serious problem in our data set. Outliers. So you must know how to deal with the outliers. But in this semester, I'm worried about removing influential observations. But if you suspect that there's an outlier which is affecting your results, you can look it from what? From the scatter plot of the histogram, the standardized residuals. If the error is above, if the error is above 3 plus or minus 3 standard deviation, then now you can say one is getting problems in my data set. You can remove it and run the results again without that observation. So what you do here, it means it will make your what? It will make your problem to be unbalanced if you keep on removing variables. But if this one, usually you have to do it when I give you an assignment. If you have some outliers, you must see how to deal with those outliers. So if you have 3 outliers, you remove the one which is the highest, you run the results. If you get another outlier, you keep on moving until you don't have influential observations in your data set. Now I want to go back to the variance. How do we make our variance to be constant? This is the important part, guys. We have to make sure that our variance is constant. So the constant variance assumption, if the constant variance assumption is violated, sometimes we can ask you to what? To transform it. I specified that there are a lot of tests that can be used to check for if variance is constant or what. But for our class, we focused on the Hartley's test, the one that we did last week. So this is the Butler's test. If you check my previous question papers, you will see this information. Some of my questions I was asking students to test for if the variance. If you can check the null hypothesis there, guys. If you check this part, it's similar to the Hartley's test, right? Do you remember the Hartley's test? What we are testing? We are testing if the variance of the treatments are equal, right? So even this test is the Butler's test. You are testing the same thing like what we did with what? With what do you call that? Hartley's test. You will need the standard deviations. You will need the standard deviations of each treatment, like what we have done in the quiz. Exactly what we have done in the quiz. You will need the sample variance of each treatment given by this formula here. So the Butler's test is similar to the Hartley's test, and it's not that complicated compared to Levin. So now we can focus on 2 ways of checking if the variance is constant. We can use the Butler's test or Hartley's test. So please familiarize yourself with this Butler's test because you are already fine with what? The Hartley's test. So the last part now, this one, ignore it, guys. modified Levin test. This one, it needs a lot of information because we have to find the standard deviation, but it's doing what? The same thing with like Hartley's and Butler's test. So this one, should not worry. Ignore what? Ignore the Levin's test, because the method will you take a lot of time doing it. The last part is this one, which is important. If the variance is not constant, it can get a serious problem in your data set. So you must know how to transform your data set. I can simply say use the square root method to transform your data set. I can say transform your data set using the square root method. And from there, check if the variance is constant. Or I can simply say that if the variance is not constant, please transform the data using the square root method. And then you continue with the analysis. I thank you. So if we have questions based on this part, let's reserve it for tomorrow tutorial session. I thank you. Enjoy.
Sir.
Yes.
Sir.
I'm listening.
Yes.